question that we have is a pretty modern question. We have been given A to be a first order reaction and the activation energy of the reaction is given. It is also given that 20% solution of A kept at 25 degrees Celsius for 20 minutes decomposes 25%. We need to find out the percentage decomposition in the same time in 30% solution of A at 40 degrees Celsius. We also have to assume activation energy to be constant throughout the temperature range. So for solving this question, you must first remember the Arrhenius equation, that is K is equal to A e raised to minus activation energy upon RT. Here K is the rate constant, EA is the activation energy, T is the temperature, and R is the universal gas constant. Now we know that for two temperatures there will be two different values of K. Let them be K1 at T1 and K2 at temperature T2. We can write ln K2 upon K1 is equal to EA upon R into 1 upon T1 minus 1 upon T2. This can be easily derived from this formula. You should remember this very important result, which gives you the variation in the rate constant with temperature. So now if we apply this formula, we will get a ratio of K2 upon K1, since we know EA and we know T1 and T2, therefore we will get a ratio of K1 and K2. Therefore ln K2 upon K1 is equal to activation energy, that is 70 into 10 raised to power 3 upon R, that is 25 upon 3 into 1 upon T1 minus 1 upon T2. 1 upon T1 was 25 degrees Celsius, therefore we will write that in kelvins. That becomes equal to 298 minus 1 upon 313. On solving this, we get the ratio K2 upon K1 to be equal to 3.872. Therefore we remember this now. Now we know that KT is equal to ln of C0 upon Ct for a first order reaction, since it is given to be a first order reaction. Therefore we write K1 into 20 minutes is equal to 2.303 log base 10 C0 upon Ct. Now this 20% solution is given just to confuse you. This will not matter when we take the ratio. Therefore when it is 25% decomposition, initially it was 100, then it will be 75 at time t. Therefore on solving this, we get the value of K1 equal to 0.0143 minute inverse, and using this we get K2 is equal to 0.0557 minute inverse. Now we know K1 and K2. What we needed to find out the percentage decomposition was nothing else but K2. Now we can write K2T is equal to, for 40 degrees Celsius the rate constant is K2, therefore we write K2T is equal to ln of C0 upon Ct. Now again this 30% has no relevance because we are taking ratio, therefore we write here 0.0557 into 20 is equal to 2.303 log base 10 100 upon 100 minus x. The percentage decomposition is x. Now on solving this, we get the value of x to be equal to 67.17%. So final answer for the percentage decomposition in same time in 30% solution of A at 40 degrees Celsius comes out to be equal to 67.17%. This question was pretty simple if you remembered all the formulae, and also this one, a very important formula, ln K2 upon K1 is equal to EA upon R 1 upon T1 minus 1 upon T2. And do not get confused by these changes that are made just to confuse you. So final answer is x is equal to 67.17%, that is the percentage decomposition.